In this video, I'd like to walk you through an actual Gage R&R study using some of the templates that are inside QI macros. We'll look at a formal Gage R&R study and then the simplified range method, the technique that we'll end up using in the catapult case. Let's take a look at each. Okay, I'm now in Microsoft Excel and I've loaded the data file that's on the course website called Gage R&R Range Method 10 Shots. But you can also get to a Gage R&R template file by pulling it up from QI macros. So I'm going to show you how to do that as well. I'll eventually be coming back to this range method 10 shots file because it's actually got some completed data that we'll be looking at. But to get a completely blank template, here's what I would do. Let's just create a new blank workbook. From any blank workbook, if you go inside the QI macros menu and then choose the tab called DOE, Design of Experiments, Gage R&R, FMEA, FEMA, Failure Modes Effects Analysis, and choose that submenu. And then scroll down to the Gage R&R MSA option. That'll give you the same template that we're actually working with some test data. So that those files located right here. And I'm going to load up now one with some data that's already placed in. All right, I'm in now the Gage R&R range method 10 shots worksheet. It came straight from the QI macros template that I just showed you a second ago, but it's got some filled in data. First, let me walk through the tabs down below, the worksheet tabs, because there's some really good stuff in here. First, instructions for each of the tabs is described on how to use each one of these worksheets, along with a bunch of great links to outside resources. Remember, all of the templates were created by the AIAG, the Automotive Interest Action Group. And you can pull them off of the web, but QI Macros has done this already for you. So instructions for each of the worksheets below. I'm going to be focusing on the Gage R&R MSA, the Gage R&R 30 part, and the range method technique that we'll be using in our catapult case. Let's start with the Gage R&R MSA 4th edition. This is the classic study, and I'm going to zoom in. The top part that I'm highlighting here contains yellow cells where you input your test information, your measurement test information. There are instructions off on the right-hand side. And if we scroll down, it's where the results of the study show up here, and we'll walk you through what this means in a second. Let's zoom in so that you can see what you'll be entering. So in a Gage R&R study, there are going to be multiple appraisers, measurers, folks dedicated to the measuring. There will typically be multiple parts, and in this example, we've got 10 different parts that you could be measuring. So let's say that we pulled off of an assembly line 10 different golf balls that are being measured. And then the parts would each be blindly labeled, so no appraiser knows that they're measuring a different part on any random basis. Only the folks that are recording the data from the appraisers would know that. And then each appraiser will record that or will measure that part multiple times in this template, up to 5 times. So you've got up to 3 appraisers, you've got up to 10 parts, and then you're going to have them measure those 10 parts up to 5 times. In this example, we've got 2 appraisers, we've got 3 parts, and we have them measure each part twice. After you've recorded all of your test data in the yellow fields, then QI Macros is set up to record the results, and I'll zoom in a little bit here so that you can see the results. Down at the bottom, of the template, you'll see that it's broken down into a couple of columns here. Your percent gauge R&R using total variation, that includes part-to-part variation, and percent using tolerance. I typically use the little bit more stringent percent tolerance value. Some organizations use total variance. We'll see the difference as we walk through each of the examples. So in it, what it's saying is with the recorded values above, the percent equipment variation that was recorded is 39%. The appraiser variation is 9%, 9.7, and the total R&R, gauge R&R, the total gauge R&R variation is 40%. What that's saying is, of all the variation in the data that was collected, 40%, almost 41%, can be associated with the way that you're doing the measuring, not necessarily in the process and process performance itself. Using our rules of thumb where anything less than 10% is a good measurement system, anything over 30% is a bad measurement system. What this tells me is we've got some work to do on our measurement system before we can use any of this collected data on analyzing current or future state in the real process improvement project. Now, one of the nice things about the templates in QI macros is that in addition to providing you with the template and doing the calculations, giving the breakdowns at the bottom, it also gives you some suggestions on if your repeatability value is high, what to do, if your reproducibility value is high, some of the root causes that might be associated with each. There's a really good Gage R&R white paper written by the QI Macros folks describing these two columns in greater detail along with all of the calculations. It's a little bit detailed. It's an optional reading. You can grab it off of the QI Macros website, and I also make reference to it in the course materials. Definitely an optional read, but if this is something that you do a lot of in your organization, might be important for you to bone up on all the details. The other tab here is a 30-part study. So instead of measuring 10 parts, this one is just built to record 30. And then the last one is a simplified way of doing Gage R&R, where you'll have two appraisers and they will only measure the part once. And what we'll be looking for is the range between the two values. This simplified approach reduces the amount of effort to perform the study, but you have to include some more assumptions. It doesn't allow for the breakdown of equipment variation versus appraiser variation. It just gives a percent total. And you have to know what your overall process variation was over the long term. So I give you three typical ways that this is done. You've got population data. You've got a sample, but you're using it as a proxy for population data, or you've got subject matter expertise, subject matter experts that have in the past calculated one of the first two items, and we use their experience to place the value in here. What I've included is example shot data from a catapult device, and you can see how even though they were observing the exact same shot, shot 1 through 10, the different appraisers recorded different values. Definitely a case of measurement system variation, measurement system analysis variation, and in the results of this, the total Gage R&R percentage was 35.9% with these values. So what that would tell me is that before we could even use this data in an analysis of current state or future state, I would have to first clean up the measurement system. Too much of the total variation that we're recording is just due to the poor way that we're doing the measurement. I'd be working on then a mini process improvement project within the bigger one to clean up the measurement system, come up with a more robust way of doing measuring. Try to reduce this value, percent Gage R&R, down to something below 30%. If I get that below 30%, then I feel comfortable that most of the variation that I am recording is a reflection of what's really going on in the process, and I can use it for describing current state and describing future state. So now you've got a couple of different ways to do measurement system analysis and specifically Gage R&R. There are many other tools. These are the only ones that we're going to be looking at and practicing in the course, but a lot of other, including bias test, linearity test, and others. I encourage you to open up the template and play around with it. And for more details, take a look at that white paper. I think that'll do it for the Gage R&R walkthrough using QI macros. We'll use this range method approach in the catapult case, and there'll be some. I think I'll create another video that describes the catapult and how folks went about measuring and collecting this data, and I'll provide the data set for you so that you can perform your own analysis.